Okay, so today I will just all the files are now available. It is uploaded today, and you can see those files as well. You can get the video also. This time there is a change in the video in the new version possibly. It is that there is a folder in this files that recording or something like that. So you can see that recording, video recording there. Anyway, so as far as did you? I hope you must have that in your mind that what is taught on the last term that we first differentiate y prime equal to fxy from either xn to xn plus 1 or x something of that kind. I mean, depending on that integration, the name of the methods are given there. So let me come back to that, and then you have seen that there are another change was there. With that, you get the different method that in points, the points which you have taken. If you remember the Adams Bashforth method, then the points were taken as xn minus 1 to xn minus p. There was no xn plus 1 as far as the interpolating points are concerned. And for Adams-Moulton method, we have taken xn plus 1 to xn minus p minus 1 means in fact basically in totality if we see the p plus 1 number of points were there, and then the integral slope that we say that y prime was approximated using your backward Newton's backward formula. And then with the simple substitution, we have seen a nice form. And then so there was one thing which you could not see, that was the error part. Okay, so okay, that I will come back later on. That was the trouble on that day. So as far as the Milne-Simpson method is concerned, everything is same almost. The different exactly what I have just explained, that the integrating limits are changed. The next one is the points are changed. Depending on that, your the methods name are coming. So in Milne-Simpson method, there is one correction actually. It is not showing here. The note is there. You just note down this on page number 6. You note down this first. On page number 6, you are able to hear? You people are able to hear?
Yes, sir.
Okay. So note down that. It is written on page number 6. The interpolate y prime t at p plus 1 points xn plus 1 dash 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 xn minus p plus 1. You just change that. It is so write down that on your register. The points are for your Milne-Simpson method. The points are xn plus 1 to xn minus inside the bracket p minus 1. Inside the bracket p minus 1. Did you understand that?
Yes, sir.
Okay. Basically, it is xn minus p plus 1, whichever way you understand. If you put the bracket, then it is xn minus inside the bracket p minus 1, right? So up to p minus 1 points, basically we are going. Since we are taking exactly like Adams-Moulton method, if you remember that xn plus 1 to xn minus p minus 1 inside the bracket, it is done. So it should show here. I don't know why it is not showing the notes. The blue, the yellow note mark is there. So possibly once you download, you may see that. I don't know why it is not showing here. Maybe because of that MS Team, it is not showing here. Anyway, so here there is, if you see the difference between Adams-Moulton method and Milne-Simpson method, points are exactly same, xn plus 1 to xn minus p minus 1, but the integration is from xn minus 1 to xn. And there the integration was from xn to xn plus 1. I think in Adams-Moulton method it is xn to xn plus 1. Yeah, xn to xn plus 1. Right? Now, exactly same process will follow that y prime we interpolate at these points using your Newton's backward formula, putting the points from xn plus 1 on the backward side to xn minus p inside the bracket p minus 1. This is what is done, xn minus 1 to xn plus 1. It should be xn plus 1 rather than xn. So xn minus 1 to xn plus 1, it is integrated, and ppt, as you know, that we have written for the approximate polynomial of degree p, and that you know it can be written as t minus, that general formula will be your in the summation form, summation j running from 0 to p. I think let me go back. Otherwise, because that day there were several things. I don't know whether it is written in the submission form earlier or not. Yeah, it is written. Anyway, I will just go back. Otherwise, everything will get messed up. Yeah, I will just revise quickly. Adams-Basforth method. We have this integration yn plus 1 to yn. It is integrated from xn to xn plus 1 equal to inside the bracket, inside the in the integral f of t yt dt, right? And then we have written this y prime, the interpolating polynomial for y prime at the points your xn I mean in the reverse order. If we say it is from your xn to xn minus p, and then the interpolating formula will be your ppt will be your yn prime t minus xn by h backward operator del yn prime, and t minus xn minus 1. So by 2 factorial h square del square yn prime, and so on. So suppose we want to write in terms of summation, so this will be your summation, and then t minus xn, that power you will write, divided by s to power, and then factorial also will be there. So accordingly it will be there. So you can write this in the summation form, and then your error term will be the last term, that will be your, it will have all the products. So let me finish this this error part also. T minus xn minus 1. Here we see in the end where we have terminated the thing up to 1 less t, instead of xn minus p, it is xn minus p plus 1. So that is your p minus 1 basically. Inside the bracket, if you see p minus 1. So error will have all the terms with your y prime p plus 1 xi, and these things were, so I will just come back to error. So tn plus 1 y is integral xn to xn plus 1, all the products divided by p plus 1 factorial y p plus 2. This I have already explained. It is y prime p plus 1 derivative of y prime, so that becomes p plus second derivative of y at the point some xi. and then this is a constant, this is a constant, so those things will come out, and the remaining you can write in terms of your s to power in terms of s, and then that I have already explained earlier. So just by writing that all those things, you will see that it is the inside the integral, it is 1 by p plus 1 factorial, inside the integral 0 to 1 integral s plus 1 to s plus p ds, and then we can write that as gamma p plus 1. If you see the definition here, the gamma j is 1 by j factorial, and this goes up to s minus j minus 1. So here it is, it goes up to s plus p, so accordingly we write it is your gamma p plus 1. So the local truncation error will be Tn plus 1 will be your gamma p plus 1 s to power p plus 2 and p plus second derivative of your y at the point of xi, and then it is written in terms of summation later on. So exactly the same way we see here in the Milne-Simpson method. You may write the each and every terms, or you may write in the summation form. In the summation form, it will be j equal to 0 to p 1 by j factorial s to power j del the backward operator to power j power j yn plus 1 xn minus 1 to xn plus 1. The only difference in the Milne-Simpson method is your from xn minus 1 to xn plus 1, and then the products are there, that is t because here we have started from xn plus 1 to xn minus p minus 1. So it will be your t minus xn minus 1, t minus xn, and t minus xn minus j, it is basically minus 2, and then because it has to go up to p, so the last will be your j xn minus j plus xn minus p plus 2, and the last term will go there in the local truncation error. So that I am not writing here, the local truncation error here. So this you can calculate, since it is already I have explained those things, how you can write these that your integrals. So here it is your delta naught will turn out to be 2, because it will be from minus 1 to 1 into ds. Minus 1 to 1 ds will be the total length is your minus 1 to 1, that will be 2. So because of that, it is delta naught is coming 2. Delta 1 is coming minus 2, that you can with your s minus 1, minus 1 to 1, it will be s minus 1 ds. So you can calculate, that will be your minus 2. Delta 2, you just calculate it everybody. Calculate this delta 1, delta naught and delta 1 quickly. Delta naught is your minus 1 to 1 ds, that is obvious. Delta naught is obvious. You at least calculate delta 1 and delta 2. Everybody. So write delta 1 as, take your register quickly take your register. Delta 1 will be, anybody? Sneh Bandhu?
S minus 1 S ds.
Minus 1 integral minus 1 to 1 s minus 1 ds.
Yes, sir.
Quickly calculate the value, whether it is coming to be minus 2. Avilas Sinha?
Yes, sir, it is minus 2.
Avilas Sinha? Avilas Sinha? Are you there? Vardhan? Yes, Avilas Sinha?
Yes, sir.
Vardhan, you are there? Okay.
Yeah. Yeah.
Naman? Naman?
Sir, talking to me only? So because
Yes.
actually there are two Namans.
Achha, there are two Namans. Okay.
Yes.
Okay. Okay. Did you get this delta one?
Sir, I'm trying only, like I was quite confused in the theory, so I'm trying to figure out that only.
No, write down delta one. Write down, I'm telling, I'm dictating. Write down delta one equal to integral minus 1 to 1
Yes,
s
sir.
minus 1 ds.
Oh. Sir, can you repeat, please?
Integral minus 1 to 1. You don't have register?
No, sir, I have.
So minus 1 to 1 s minus 1 ds.
Minus 1 to 1, S minus 1 ds.
Right.
Okay,
Snehbandhu,
sir.
you go for delta 2. Check whether it is minus 1 by 3. So delta
Yes,
2
sir.
will be what? S minus 1 into s
S
ds.
ds divided by 2 factorial.
Yeah, obviously. Follow me?
Sir, delta 1 is minus
Tell
2.
minus delta 1 is minus
So
Minus
minus
2,
2.
sir.
your
So
voice is
someone
not coming. Minus
minus 2.
right. So keep this in mind. I'm repeating again. I have told on that day also that if your integral is written as s minus 1 s plus 1 like that. So the first one will be your minus 1 to 1 1 into ds. Second one will be minus 1 to 1 1 into s minus 1 ds. Third one will be minus 1 to 1 s into s minus 1 into s ds like that. Right? Is that clear to everybody?
Yes,
Yes,
sir.
sir.
Okay, fine. So then after that, things are just repetition of the previous one. So you can, I have already explained that also. That part is there in the end, which I explained on that day using your backward one. I think for Adam Basforth method, I have told you. So order 1 method will be yn plus 1 equal to yn minus 1 plus 2 hyn plus 1 prime. You see again that this is your f of xn plus 1 yn plus 1 means that this will be
Implicit.
explicit or implicit method?
Implicit.
Implicit method, right?
Im-
And is that clear?
Yes, sir.
Okay. So similarly, you can calculate other order methods. Now, the problem is that implicit method that you have to apply.
Newton-Raphson method.
Newton-Raphson method. Now, the question comes that can we avoid this? Can we avoid this? Can we do something else? So the answer is yes, and that is the next method. The theory part I will take up on the Saturday. There are certain theory part which I have to explain you people. Theorem proof is not there, but theorem I will state and then I will explain those things. So, so that is called the predictor corrector method, right? The next method, which is your predictor corrector method, that takes care of this thing, this type of implicit method. What we do in that? What we do in that? The name itself suggests that something is predicted and something is corrected. It is, the name is predictor corrector method, right? So the name itself suggests something is predicted and something is corrected. So it will be combination of the two types of methods. First is your explicit method. With that, we'll predict something. And the next one is that this is an iterative process. This is an iterative process, right? Next one is your implicit method. Implicit method means, for example, if you want to find out y1, then it depends on y1. Is that right? Implicit method means, suppose you want to find out y1, then the right hand side also has y1. Is that clear or not?
Yes, sir.
Is this true or not? Okay. Now, suppose we want to run an iterative process. Suppose we get the initial guess for y1. So that we can put on the right hand side or wherever it is y1 is there, right? And then left one side, left side y1, that will be improved. Is that right or not? I will show the slide also. First, you try to understand what is the philosophy behind that, right? So we'll predict y1, y0 is given, y1 we can calculate using your explicit method. So y1 is available. So we'll take this as the initial guess for y1, and then we'll put on the right hand side of your implicit method to get the new value of y1, and we'll continue this process. So let me share that slide, and then I will. See, the name is whether you are able to see this slide.
Yes, sir.
So the name itself is your predictor corrector method, right? So what we do, we take one implicit method. Let me explain here. Let me take the example directly, and then I will explain that. You see, here there are two methods are written here. One is your yn plus 1 equal to, either we say that y1 plus hyn yn prime, or we say that yn plus h times your fxn, right? Fn. Next one, this we call as predictor one. Next one is your we call it corrector one. This is your implicit method. That is your yn plus 1 equal to yn plus h by 2 yn plus 1 prime. C yn plus 1 is also here, and then plus yn prime means basically f of average of the slope at the point xn plus 1 and average of the your at the point xn. So it is the average of the slope f of xn plus 1 yn plus 1 plus f of xn yn. So what we'll do to start with, or let me first explain the general one. Yn plus 1 0. This means the value of yn plus 1 will first find out using the using your explicit method, which is given as the predictor method. So that's the reason P is written here. So yn plus 1 0 is your yn plus your hfn. For example, if we want y1 0, this will be y0 plus h into f0. So right hand side we can evaluate, and so we get that y1 0. So y1 0 can be predicted from this explicit method. Next, what we'll do, we'll try to improve this y1. Means if we write here y1 1, that will be your y1 plus h by 2 f at the point this is n equal to y1 I have taken n equal to 0. So this is f1 plus f0. But here f1 means x1 y1. Y1 will take as y10, which we have got using the predictor method, so that we can evaluate the right hand side of this. That is your y1 plus h by 2 f of x1 and y10 plus f0 y0 is already there. Is this clear point? The first step is clear.
Yes, sir.
First step is clear. Call
Yes, sir.
me, are you there? Call me Chaudhary. Call me Chaudhary. If I call and you are not there, then your attendance will not be counted. So okay. Next, what we'll do, once we have got the improved value of y1, then we'll evaluate the function value. So let me take the complete numerical example, and then I will come back to the theory. This is why the problem is, you know it very well, y prime equal to minus 2t u square, u prime equal to minus 2t u square, u0 equal to 1. We take h as 0.2 on the interval 0 to 0.4 using your PC method or the predictor corrector method. Predictor method is given as un plus 1 equal to un plus h by 2. You will see that this is one of the Adam-Basforth method. 3 un prime minus un minus 1 prime. This is an explicit method. You can calculate. The only trouble here is that we cannot start with y1. We have to start with y2 here. Because n minus 1 is there, and then corrector method is given as I was explaining for the general one. The un plus 1 equal to un plus average of the two slopes at xn plus 1 and your xn. Now your subdivision is there, x0, x1, x2, everything is there. You understand those things, and then y1 y1 is calculated through some other methods, and then we'll start. You may take Taylor's method, you may take the RK method, Runge-Kutta method, any order. There is one more thing which I have to show, that some classical Runge-Kutta methods also. So a lot of things are there which because of that last turn trouble we could not see that. I could not explain that. So for n equal to 1, so basically it will start from n equal to 1. So y1 is calculated or u1 is calculated through your Taylor's method, RK method, or any one of that kind. And then since the predictor method starts with your u2, so we'll calculate u2 using that u1 value which we have got using either Taylor's method or the RK method. So u2 0 will be your u1 plus h by 2. This is your, you write down these two methods. Write down these two methods on your register. This P and C. Write down these. Otherwise, every time we have to go back there. Write down these methods, these two methods quickly. Once you write down, you just inform me quickly.
Done, sir.
Okay. Everybody
Sir,
has written that? Tell me.
Yes, sir, done,
how
sir.
we are getting this predictor method? How we are getting these equations of
How
predictor?
we get? How we
The
get?
that equation of predictor.
No, it is given to you. As far as the exam is concerned. As far as your own problem is concerned, you have to choose some of the explicit methods.
Okay, sir.
Is that right?
Yes, sir.
Unless until it is given or you choose on your own for your own problem. how you can proceed? You cannot proceed. Method should, so basically it's a combination of two methods. One is your predictor, means some explicit method. Another is your some implicit method. So a pair of implicit and explicit methods are there. The explicit method will be used to predict the first value. That's all. Nothing else. It will not be used further. And continuously will improve the value using your this implicit method. Is that clear?
Yes, sir.
You will see that. That's the reason I have taken the complete numerical example. See, so for n equal to 1, if you see the predictor method, it is your u2 equal to u2 plus h by 2, sorry, h by 2 3u1 prime minus u0 prime. Is that right?
Yes.
Is that right?
Yes.
Okay. Okay. Then you just put the values. U1 is known to you because just now we have calculated, and then U1 prime you can get using your U prime equal to F, right? So U1 prime is also known. U0 prime also you can get by using your U prime equal to F. So that is that turns out to be 0 for this because X0 is 0. And F is your minus 2t U square. So that case it is 0. So basically you put all these values, you get U20. This we have used the predictor method. This here we have used the predictor method. So U20 will fix it as U20, the initial value for U2. Is this clear?
Yes, sir.
Is this okay? So next what we'll do, we'll evaluate the function. This is intermediate step, but anyway, since it is written in the book, so I will explain that. Next, what we'll do, we'll evaluate the function that is your u prime equal to f at this point, u20. So f t2 u20 turns out to be minus 2t2 u20 square. So that put the value, you get the value. Is that clear? So this is evaluate the function. Is this clear? Is this clear?
Yes, sir.
Okay. What next we'll do, we'll improve this u2. We'll improve this value u2 using the implicit method. Using the implicit method. Now, for n equal to 1, if you see the corrector method, it is your u2 equal to n equal to 1, it is u2 equal to u1 plus h by 2 means average slope of your average slope at your u1 and u2. But u2 value will take u2 0. u2 prime, it will be u2 prime 0. That we have already got using the predictor method. Is that clear? Is
Yes.
that clear? So now the right hand side, everything is known. U1 we have, U2 prime 0 we can get by since U2 0 is known to you, and then U1 prime since U1 is known, so U1 prime is known. Everything is known on the right hand side. So once everything is known, put all the values and then you will get the improved value for your U2. So that is fixed as U21. So U21 turns out to be this quantity. Next, we'll again evaluate the function at this U21. We'll evaluate the function at U21. So then that's the reason E is written here. Evaluate. Next, again we correct it. U2 value further we correct it. So U22, since it is an iterative process, so it is going like this. But you see, there is a difference between this iterative process and your Newton-Raphson method. There we have to calculate several values. We have to divide, and then we have to. So the number of calculations are more. I mean, the complexity is more there than this PC method. So U22 will be your calculated through your the earlier improved value U21. So U22 will be your U1 using your implicit method. U1 plus average slope at your U2, but that is the U2 value will be taken as the previous value. That is your the previous available improved value. So that is your U21 and then U1 primes. Put all the values, everything is known. So put all the values, you get the next improved value U22, right? Is this process clear?
Yes, sir.
Others also?
Yes, sir.
Okay. So this process will repeat. So that's the reason you may find in the book that it is written as P, E, C, E, and then C like that. Means this sequence is there that predict, evaluate, correct. Then evaluate, correct. Evaluate, correct. How long you will go? How long you will go?
It depend on us, like the value of further
The
iteration.
tolerance.
Like
It
4
will
to
depend
5.
on the tolerance. The number of it means suppose you want the correct up to 2 decimal place. Then once the two consecutive values are close enough up to two decimal place, you stop at that stage, depending on your tolerance. Is that right?
Yes, sir.
Okay. Now the question comes that whether this iterative process, whenever you develop an iterative process, the question immediately comes that whether it will actually lead to the solution or not, meaning by whether it will converge or not, right? So that's the question which comes in the mind immediately, whether it is going to give the actual value, the close to the actual value or not. Is that right?
Yes, sir.
Okay. So that question will answer through one theorem is there. I will take one demonstration also so that things will be clear to you people. You can understand the thing. Let me take that demonstration. You keep your register with you. Actually, you will see once I will start the start your stability part. That is the another part. We'll use this problem y prime equal to lambda y prime equal to lambda y, right? A linear problem with the parameter lambda, right? And we'll say that this is your test problem. This is your test problem. So this every method will be tested on this y prime equal to lambda y, and we'll check whether it is convergent, it is stable or not. So that's the reason whenever we require, we go for this one, the test problem. So let us take the two methods, predictor and corrector. So yn plus 1 equal to yn plus, this is your Euler method, you know it very well. The explicit method, yn plus 1 equal to yn plus hfn. So that you know. And the implicit method I have again taken yn plus h by 2, that is the average of the slopes. Is that right? Is that right?
Yes, sir.
Okay. So we'll apply on this problem. Means f is your lambda y. F is your lambda y. So now we'll first put yn plus 1. This is what we do. We first predict. Now I'm calculating the general value and try to see whether it is going to converge or not. So n plus 1 0 equal to yn plus your h, but f is your lambda y, so it will be lambda into yn, or we may write this as 1 plus lambda h yn. Is that clear? The predictor method? Is this clear?
Yes, sir.
Okay. Next one, we'll correct it. Means yn plus 1 1. Evaluation I will do next. Yn plus 1 1 will be your yn plus h by 2, and then your f is your basically your lambda, the average slope at the yn plus 1 and the yn. So it is yn plus 1 0, which we have already got using your predictor method, and that value is 1 plus lambda h into yn. So once we put this value, we will see that plus lambda yn. So we'll put this value yn plus 1 0 here. So this is your lambda 1 plus lambda h plus lambda outside yn, h by 2 is taken out. In other words, we can rewrite, I'm just moving directly, yn plus 1 1 equal to 1 plus lambda h plus lambda square h square by 2 and then yn. Up to this it is clear? Up to this it is clear?
Yes, sir.
Yes. Okay. So next we'll evaluate at this yn plus 1 1. So this function is your lambda y. So it is your lambda yn plus 1 1 and put the value of yn plus 1 1. So it is your lambda into this quantity into yn. Now we'll correct it again. So correct means we'll use the average slope things. So yn plus 1 2 will be your yn plus average slope at the point yn plus 1 and yn. At yn it will be lambda into yn. So lambda is inside, yn is out. Is that clear? This is the slope at your yn. Is that last term? Is that clear?
Yes, sir.
And then yn plus 1 1 value, this will be your lambda and then it is lambda into this quantity, means lambda plus lambda square h plus lambda previous evaluation you just see, it is your lambda cube h square divided by 2. So this is what is written, lambda cube h square divided by 2. So we get, if we rewrite it, yn plus 1 2 will be what? 1 plus lambda h plus lambda square h square by 2 plus lambda cube h cube by 4. Is that clear? Is that clear?
Yes.
Okay. This you can verify. Now, if you continue this way up to m times, if you continue this way, so what will be your, you see, yn plus 1 1 is 1 plus lambda h plus lambda square h square by 2. Means if it is 1, then up to second power we have gone. If it is 2, we have gone up to third power, 1 extra. Is that clear? Is that clear?
Yes, sir.
Now you write down yn plus
Yes,
1 mth iterate value. Yn plus 1 mth iterate value. And tell me. Yn plus 1 m will be what? Anybody? Anybody?
So it will be like 1 plus lambda h plus lambda square h square by 2 plus lambda cube h cube by 4.
Last term?
Last term will be lambda m plus 1 h m
Right.
plus 1
Right.
divided by 2.
Divided by
2m.
m plus 1.
Yes, sir, m plus 1.
Is that m plus 1? What is that? 2, no, not m plus 1. It will be your
M minus 1.
Sir, it is 2 to the power n.
yes. So it will be your lambda. Here it is not the correct one. It is not the correct one written. So it is, if you see, this is 2 square is going there, and then next value will be what? Lambda to power 4 s to power 4 divided by 2 to power? 2 to power? Tell me. Here it will be what? 2 to power?
M.
M. Because if you see 2 to power m, so the last term in the previous that yn plus 1, 2, it is 2. I mean, here it is 2 to power 1. The first term lambda square h square by 2 to power 1, and then lambda cube h cube by 2 square, and like that. Means there the powers 1 less is there. I mean the exact whatever the iterate we are finding out, right?
Yes, sir.
Okay. Now, what will be this? When this will this series will converge? This is geometric series.
If the ratio is less than 1.
So we may take out this 1 plus. Yeah, obviously that will. You may write down that 1 plus lambda h you take out. 1 we separate out. So I think somewhere it is written, but it is not correct one. So I am not showing that actually. There was one mistake actually. You may write 1 plus lambda h. Then the first term will be 1 plus lambda h divided by 2 lambda square h square by 2 square. Last term there is a difference, I think. No, it will be fine. So it will be what? Lambda h to power m by 2 to power m. So this the finite number of term, if it is added or subtracted, does not matter to a series. So if you continue for m tends to infinity, what will happen? If your magnitude of what is the common ratio?
Lambda
What
h
is
by
the common?
lambda h
Lambda
by
h by
2.
2, right? If this ratio is strictly less than 1, then the series is convergent? Yes, or
sir.
no?
Yes, sir.
Okay. So keep this in mind. This is the condition you are getting so that your process will converge. The sequence which you are getting will converge. Is that right?
Yes, sir.
Okay. So now I will go back. Here is one theorem which guarantees that convergence is there. I'm just reading it out. Let yn plus 1 p be a sequence of approximations to yn plus 1 if for all values of y close to yn plus 1 and including the values which we have that improved values n plus 1 0, n plus 1 1, n plus 1 2, and so on and so forth. We have that magnitude of del f by del y at the point t and y is strictly less than L, and L is less than 1 upon h gamma naught L. I will explain what is gamma naught L, don't worry. Basically, if I just go back to a general multi-step method, so that will be better to explain. A general multi-step method, I am writing here, yn plus 1 equal to n minus L. L means these many steps are there, the order of the method, plus h gamma naught L. Is that written? It is the coefficient of what? Coefficient of the implicit part. The coefficient of implicit part. That is f tn plus 1, yn plus 1. Remaining all these are previous values which you already have. The only trouble with this is this implicit part. So this is the coefficient of h into gamma naught L is the coefficient of. So don't remember h into gamma naught L. You just remember the coefficient of the implicit part, that is f tn plus 1 yn plus 1. Is this clear? Is this clear?
Yes, sir.
Okay. So every time this term which is creating trouble is actually coming in the your convergence part also. The this is H gamma L is nothing but the coefficient of I want to answer the coefficient of the
Implicit.
implicit part yn plus 1. Is that yn plus 1 prime or f of xn plus 1 yn plus 1? Is that clear?
Yes, sir.
Is fine. So you apply this theorem. So if this happens, then the sequence yn plus 1 p converges to yn plus 1 for sufficiently large p, right? Now, so if you apply this theorem to the problem which we have just discussed, can you tell me what will be the condition? This was the y prime equal to f is the test problem which we have taken. Y prime equal to lambda y. You apply this and see, let us see that whether you are able to understand that or not. What is del f by del y in this case? Y prime equal to lambda y. F is lambda y. So what is del f by del y?
Lambda.
Only lambda. So magnitude of lambda, it is the theorem says that magnitude of del f by del y. So this will be magnitude of lambda should be strictly less than L, and L should be
L is
less
lambda
than
by
1 upon the coefficient of magnitude of coefficient of implicit term.
Yes, sir.
In the implicit method. Implicit method is yn plus 1 equal to yn plus average slope at the point
Yn plus 1 and y.
right. So implicit part is your yn plus 1 part.
Yes,
So
sir.
what will be the coefficient?
Lambda h by 2.
No. Lambda is your f. Lambda is from your f. Coefficient of f xn plus 1 yn plus 1. Lambda yn plus 1 is full f of xn plus 1 yn plus 1. So the coefficient will be only h by 2. Coefficient will be only h by 2.
Okay, sir.
Is that clear?
Yes, sir.
So lambda magnitude of lambda is strictly less than 1 upon magnitude of h by 2, meaning by magnitude of lambda h is less than 2. The same thing you are getting from the problem directly, that you have got magnitude of lambda h by 2 is strictly less than 1, right?
Yes,
Meaning
sir.
by this implies magnitude of lambda h is less than 2, strictly less than 2. So either you do this way or you use your theorem. If this may not be possible every time, right? It depends on the problem. But to check that, you have to use only this problem, y prime equal to lambda y. You may gradually understand that why I am saying so. Y prime equal to lambda y. This is called the test function. To check either convergence or your stability, we'll use this problem. This is called the test function. Is that right?
Yes,
Is
sir.
that right? I'm not getting the voice from others. Is there any query from the others?
No, sir.
Anybody has any problem? Any query?
No, sir.
Anybody else? Swarup Ranjan Mandal? Are you there? Swaroop Ranjan Mandal. So this is what you people do. In the name of online classes, you do like this. Sharman Pal? Sharman Pal?
Yes, sir. No queries.
Okay, then today I will just close at this stage. Now all these files are available on this MS Team. You look at that. Girish? Girish?
Yes, sir.
Okay, fine. So you are there. So now you can look at these slides. You can download these files and then you just check it. Whatever things are not clear, you can ask in the Saturday class. I will explain that. And Sneh Bandhu.
Yes, sir.
Acha, you just remind me in the next class that I have to show you that slide which tells about the various Picard's like various RK methods, and I will explain those terms. Basically, the same. It is basically copied from your book, that Iyengar book. So
Okay.
I will just explain those coefficients, and there is a way to write that, and then why it is written that way, because one can remember those. That's a difficult job because there are several methods. So one can remember those, but some of the classical methods and all those things you have to remember because for your exam it is required. Adrija? Adrija?
Yes, sir.
Okay. So now you download the files and then you go through that. We'll meet on Saturday. Whatever your doubts are there, first I will clear that, because the last turn which you have seen that there were some troubles. So I will explain all those things. So basically, I have told as far as there is one more thing. You just see one. Okay, I will talk on Saturday. I will talk on Saturday. Otherwise, in hurry, telling the things will not be nice. So on Saturday, we'll see those, and I will somehow I will submit. I will upload that. I have to decide which way I have to do. Upload the assignment, and it will be time bound, and you have to submit those assignments. So almost whatever I have taught up to that, it will be there. Okay.
And sir, one more thing I want to ask, like, what is the test date for?
It is not yet decided by the coordinator. Coordinator has to tell. That has to be told by the coordinator. Once he tell, I will immediately pass on to people. Don't worry.
Okay, sir.
Right. But you continue studying. Don't leave anything.
Yes.
You do the problems. Once you do the problem, then you can understand the method. And if there is any trouble, at least you can ask in the next class. So that's the basic thing. Only few people are responding. Very few people are responding. So in the end, because you'll see that plenty of methods you will see, not one or two. So then you will be in trouble.
Now
Okay, then.
there are plenty methods.
Yeah, it is increasing. It will increase more and more, don't worry. Because it is just your first order initial value problem. Then we'll go to the boundary value problems, and then we'll go to the PDs. So a lot of things are there. But every time I will try to demonstrate through your Taylor extension. And that's the reason this interpolation or the Taylor's expansion. There is another way which I will maybe tell. I will tell that before starting the stability, or just about that. So that is given in your book. What I have taught, this Adam-Basford method, Adams-Moulton method, these things are not given in your book. It is given in Atkinson book, Numerical Analysis by Atkinson. I don't know whether it is you people can get online or not, or that I don't know. Okay.
Sir, we have the
So I will
assignment
close.
on this Saturday.
Tell me, Adrija, what is that you are telling?
We have the assignment on this Saturday.
I will try to submit that. I will try to upload that. I have to talk to the TAs also, and then accordingly it will be submitted. Is that
So
right?
like time bound means how much time we get?
Or I will upload. Pardon me. I didn't. I couldn't hear properly. Vardhan.
You told time bound assignment means how much time will we get is what I'm asking.
That depends on the number of problems. How can I tell beforehand?
Okay, sir.
Okay, I will upload that assignment at least. You start doing, and then I will give. I think the time is for your next class possibly. So we'll talk on Saturday.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.